So let's do another mirror example. Imagine we got a mirror, once again, and center of curvature is right there. Focal length is right there, okay? And so focal length is going to be equal to 14.2 centimeters. And now I'm going to put the object at 11.8 centimeters. I'm going to say the height of the object is, like last time, 1.25 centimeters. So now the object is right here. So the object is right there. So what happens? Ray diagram. The light comes straight in, parallel, goes out this way. Okay. Now I can't really go through the focal, I can't really go to the focal point there because that doesn't make any sense to do that. Okay. And so instead it'd be as if it went through the focal point and hit here, then goes out straight. And then likewise, center curvature going out straight that way. Well, the light never comes together out here anywhere. So if the light never comes together, you don't get an image. Well, if I run all these things back, they all came together over there somewhere. And so what that means is that it's as if there were an image back here behind the mirror. Okay, so, and it's upright. So that is a virtual image. Okay, so once again, we have a virtual image. So now what we want to do is we want to figure out, well, gosh, if we've got this virtual image here, then what does that mean? What does that virtual image, tell me? Okay, so, well, let's work this out. 1 over f equals 1 over do plus 1 over di. So di is 1 over f minus 1 over do to the minus 1. So for this example, 1 over 14.2 centimeters minus 1 over 11.8 centimeters to the minus 1. So di is now going to be a negative 69.8 centimeters. So that's behind the mirror. The magnification is, if you remember, it's minus di over do. So that's going to be minus a negative 69.8 centimeters divided by 11.8 centimeters. So that's going to be 5.92 positive. So the magnification is positive. So it means it's almost 6 times bigger than originally was. So the height of the image is going to be the magnification times HO. So that's going to be the 5.92 times 1.25 centimeters. So HI is going to be 5.92 times 1.25. That's going to be 7.4 centimeters. So we would say that the image was virtual, it's upright or erect. The two terms mean the same thing. You can use either one of them, okay? And we gave the magnification, we gave the height of the image, we gave the position of the image. So those are the image characteristics. That's what we would use to describe this. And again, we can do ray tracing or ray diagram same way as we did before, same rules. So ray diagrams, again, if you do it correctly, it works really well. If you do it incorrectly, then it doesn't work well, and you don't get as many points for it. You don't get points for it on the test. Okay, so there we have an example. Okay, so this is our second example.